In this video, I'm going to show you how to take photos with a ESP32-CAM board and save them in a microSD card using Arduino IDE. When you press the ESP32-CAM reset button, it wakes up, takes a photo and saves it in the microSD card. For those of you who aren't familiar with the ESP32-CAM, it's a very small camera module with a ESP32S chip that costs less than $10. It features an OV2640 2MP camera, several GPIOs to connect peripherals, and a microSD card slot. You can find a link to the product page in the video description. For this particular project you'll need the ESP32-CAM board. I'm using the AI Thinker module, an FTDI programmer and jumper wires to upload code. I've been using this FTDI programmer with the ESP32-CAM and it works well. You'll also need a microSD card to store the photos. If you experience any problems with the ESP32-CAM, we have a dedicated troubleshooting guide with all the most common problems and how to fix them. The first thing you need to do is to format your microSD card. You can use the Windows Formatter tool or any other microSD card formatter software. We'll program the ESP32 using Arduino IDE, so you must have Arduino IDE installed as well as the ESP32 board add-on. After installing everything, open the Arduino IDE and copy the code provided. Let's just take a quick look at the code. The code starts by including the necessary libraries to use the camera. We also include the libraries needed to interact with the microSD card, and the EEPROM library to save permanent data in the flash memory. Define the number of bytes you want to access in the flash memory. Here we'll only use one byte that allows us to generate up to 256 picture numbers. Then, define the pins for the AI Thinker camera module. You might need to change the pin definition depending on the board you're using. Wrong pin assignment will result in a failure to init the camera. Create an int variable called picture number that will help generate the photo name. All our code is in the setup. The code only runs once when the ESP32 wakes up, in this case when you press the onboard reset button. Define the camera settings. Use the following settings for a camera with PSRAM, like the one I'm using in this tutorial. If the board doesn't have PSRAM, set the following. Initialize the camera. Initialize the microSD card. The following lines take a photo with a camera. After that, initialize the EEPROM with the size defined earlier. The picture number is generated by incrementing 1 to the current number saved in the flash memory. To save the photo in the microSD card, create a path to your file. We'll save the photo in the main directory of the microSD card, and the file name is going to be picture1, picture2, picture3, etc. This next line saves the photo in the microSD card. Note that after saving a photo, we save the current picture number in the flash memory to keep track of the number of photos taken. When the ESP32-CAM takes a photo, it flashes the onboard LED. After taking the photo, the LED remains on, so we send instructions to turn it off. The LEDs connect to GPIO4. Finally, we put the ESP32 in deep sleep. Because we don't pass any argument to the deep sleep function, the ESP32 board will be sleeping indefinitely until reset. Now that we've taken a quick look at the code, it's time to upload it to your board. Follow the next steps precisely, otherwise you might not be able to upload code. Connect the ESP32-CAM to an FTDI programmer as shown in this schematic diagram. GPIO 0 must be connected to ground, TX goes to the RX pin, and RX goes to the TX. In this case we're powering the ESP32-CAM through the 3.3V pins and it works well. Some of our readers have been reporting problems powering it like this. So, if you have problems, try powering the camera with 5V through the 5V pin. After making sure everything is connected properly, in your Arduino IDE, go to Tools, Board, and select the ESP32 WRover module. In the port menu, select the COM port the ESP32 is connected to. For the partition scheme, select UJPP 3 MB no OTA. After having all the right settings, while GPIO 0 is connected to ground, press the ESP32-CAM RESET button to put it in flashing mode. Then click the Arduino IDE Upload button. You need to follow these exact steps to upload code, otherwise it will not work. If you are having any other issues, you may also consider taking a look at our troubleshooting guide and see if it helps. After uploading the code, remove the jumper that connects GPIO 0 to ground. Open the serial monitor at a baud rate of 115200. Press the ESP32-CAM RESET button. It should initialize and take a photo. When it takes a photo, it turns on the flash. Keep the Arduino IDE serial monitor open to see if everything is working as expected. As you can see, the picture was successfully saved in the MicroSD card. Now you can disconnect the ESP32-CAM from the FTDI programmer and power it using an external power supply. Now you can press the ESP32-CAM onboard reset button. Let it take a photo and go back to deep sleep. As you can see, it acts like a regular camera that takes a photo after pressing a button. To see the pictures, remove the microSD card and insert it in your computer. You should have all your photos saved. Here are some of the photos taken with the ESP32-CAM. You could modify the code to take a photo every time it receives a certain message on an MQTT topic, for example. I hope you like this project. For more details and complete code, visit randomnerdtutorials.com or click the first link in the video description. We have other projects with the ESP32-CAM about face recognition and video streaming that you can watch on my YouTube channel. Thanks for watching and don't forget to subscribe for more ESP32-CAM projects.